In the last two lessons, you have learned to solve systems using graphing and also the substitution method. In this lesson, we will learn to use the elimination method in order to solve the system of equations. Now you can use the property of addition with equations and also the property of subtraction. But in this first example, we are going to use the property of addition. We are going to combine two equations in order to eliminate one of the variables. Okay, so I'm going to demonstrate that now. This direction says um, to solve by elimination, so we are going to combine the two just like we would add normally. Okay, we're almost ignoring this equal sign here. Okay, so if I'm going to add these two, then that means I'm going to have a 2x plus a negative 2x, which is the same as subtracting. So 2x minus 2x, which gives me 0x. Now I'm going to combine my y's, and I have a 3y plus a positive 9y, which gives me 12y equals, now 11 plus 1 is 12. Okay, so obviously if we have 0x's, we have nothing there because 0 times anything is 0, so we're left with 12y equals 12. Divide by 12 on both sides, and we're left with y equals 1. Now, we have a y variable. So simply, now that we've eliminated the x, we found what y was, then that's going to be the case for both equations. So we can use either one of the other equations to be able to figure out what x is. So I'm going to pick this first one. That's just a normal habit that I have, is to plug into the first equation. So I say, I'm going to rewrite my first equation. Okay. Now I'm going to plug in this value for y right here. Okay, so I've got 2x plus 3 times 1 equals 11. Okay, so I plugged it in. Now I'm going to solve for the other variable. Okay, we've already found y. We need to find x. So 2x plus 3 times 1 is 3. Okay, so now I'm going to subtract 3 from both sides because I can get rid of that right there. Okay, so I have 2x equals 8. Okay, now I just have a one-step equation left, so I divide by 2. Okay, to get rid of that right there. I'm left with x equals 4. Now, as we've seen previously with graphing and substitution, then if we solve a system of equations, two linear equations like we've been talking about, then the answer or the solution would be a coordinate point. Okay, so I'm going to leave my answer in coordinate form, like I've got x, y. Okay, so my answer would be 4, 1. Okay, so that would be my answer. All right, so moving on to example 2. All right, now sometimes it's not so simple. We can't just simply uh, add or subtract one from the other right here in order to solve this problem. Because if we did that, we wouldn't have one eliminated. Okay, so the trick here is going to be that we're going to try to multiply one whole equation by something so that we can make it where we can eliminate it. So if you notice, if we multiplied this 2 times 3, we would get a negative 6. Okay, so which means if we had a positive and a negative, we can obviously add those two together and they would go away. Okay, so since I see that, I'm going to multiply everything in this equation by 3. Okay, all right, so I'm going to go rewrite the problem over here. We got 3x plus 6y equals negative 6. Okay, and now when I multiply everything in here, it's just like the distributive property, very similar. Okay, so we're saying 3 times negative 5x is going to be negative 15x. Okay, 3 times negative 2y is going to give me a minus 6y. 3 times negative 14 is going to give me a negative 42. Okay, now just like in the last problem, we're simply going to combine these two. Okay, so in order to get rid of this y, all I have to do is add these two together. Okay, if they both had the same sign, I would subtract, obviously, but since they have different signs, we just simply add. Okay, so what is 3x plus a negative 15x? That's going to give us a negative 12x. Okay, so positive 6y plus a negative 6y is going to give me 0y. Okay, and now negative 6 plus a negative 42 is going to give me negative 48. Okay, now obviously if 0y means 0, so I'll rewrite my problem here. Have negative 12x equals negative, negative 48. Okay, so if I divide both sides by negative 12, then I'm left with x equals a positive 4 because we have a negative and a negative that can cancel out. Okay, so I have my x value. Now, just like we did last time, I plug into one of the original equations. Okay, my habit always is to plug in the first one. You don't have to plug in the first one every time. You can plug in the second one, but my habit is the first one. So I'm going to take 3x plus 6y equals negative 6. I'm going to plug in that value for x. So 3 times 4 plus 6y equals negative 6. Okay, so 3 times 4 is 12 plus 6y equals negative 6. All right, I'm going to subtract that 12 from both sides. All right, I'm left with 6y equals negative 18. All right, now one step equation left, so I simply divide by 6. I'm left with y equals negative 3. Okay, like we discussed in the last problem, the answer or the solution to solving a system of equations is going to be a coordinate point when we're talking about linear equations. So my answer this time would be 4, negative 3. Okay, and I'm done with that problem. Okay, now moving on to example 3. This time, once again, I'm going to show you one more trick. Okay, now I look at these and I see nothing that I can combine right off the bat that will allow me to eliminate, just like in the first one. And in the second problem, we simply multiplied one of them and got a number to match up with another, like one coefficient to match up with another coefficient. But in this case, we don't really have that opportunity. Okay, when we're talking about our coefficients of x and y, 3 won't go into 5, 5 won't go into 7, and vice versa. None of those will work. Okay, so now in order to eliminate, we will multiply both equations by something. Okay, so in this problem, we're just going to take those coefficients that are in that first part right here, the 3 and the 5. Okay, those are my smallest numbers, so I always like to choose the smaller numbers that I can. Okay, and kind of like when we find a common denominator with fractions, kind of a similar concept there, we're going to multiply each equation by the other coefficient. So I'm going to multiply this one times 3. I'm going to multiply this one times 5. Okay, sorry, 5 right here. All right, so this is going to be 5, and this is going to be 3. Okay, now see what happens when we multiply these together. Okay, I'm going to rewrite this over here. 5 times 3x is going to give me 15x. Okay, 5 times positive 5x, or 5y, I'm sorry, is going to be 25y. And then 5 times 10 is going to give me 50. Okay, sorry, that looks like 56. All right, now I'm going to take my 3, multiply it times 5x, and I get 15x. Now 3 times a positive 7y will give me plus 21y. Okay, and 3 times that 10 is going to give me 30. Okay, now If we did it exactly like last time, we would end up with 30x plus a 46y and 80, okay, which doesn't eliminate anything, okay? So instead of using the addition property, then this time let's use the subtraction property. Okay, so I'm going to subtract everything in this line from the top line, okay? So 15x minus 15x is going to give me 0x. Now 25y minus 21y is going to give me a positive 4y. 50 minus 30 is going to give me 20. Okay, so since that's eliminated, that's a 0x, so we're done with that. So 4y equals 20. I'm going to divide by 4, so I can do that right there. I'm left with y equals positive 5. Okay, now, just like in every other problem, we're going to take this value for y that we just found, and we're going to plug it into this original equation. Okay, so one of the original equations, and I always go with the first one. So 3x plus 5 times 5. Okay, I just simply plugged it in right there where that y was. Okay, equals 10. Now, 3x plus 5 times 5 is 25 equals 10. All right, now subtract the 25 from both sides so that we can get rid of it. We're left with 3x equals negative 15, because a positive 10 minus 25 is going to give us a negative 15. I'm going to divide by 3. Okay, both sides. So I'm left with x equals a negative 5. Okay, now this is my x value, this is my y value. So my coordinate point is going to be negative 5, 5. Okay, and that is my solution to the system, or the system of equations. If you have any more questions, make sure you ask your teacher first thing tomorrow. Thank you.